Hi guys, Ernest here. I'd like to welcome us to our Ernest's Sciences and Mathematics TV channel. So today we're going to look at one of the methods that we have been employing in some of our videos, or rather we're going to employ in some of our videos in trying to show the movement of charges across molecules. So in this particular case, this concept is referred to as arrow pushing. And arrow pushing is going to assist us monitor the movement of a formal charge or the movement of electrons from one part of the molecule to another. And basically, as we had said, that the interaction of valence electrons are going to form different types of bonds in compounds. And this is, of course, is the essence by which, of course, various compounds are formed. And therefore, the movement of charges from one compound to another is going to assist us to monitor the various reactions that we're going to encounter. And this is going to entail the overall concept of reaction mechanisms. And therefore, we are going to consider a particular case in our this specific discussion, which is this is a concept of a protonation, which is going to assist us, of course, have an illustrative example on how we can be able to discuss this particular case. So this concept of protonation, I'm going to consider a case of ammonia. So we had said that ammonia is a tetrahedral compound that can be able to be illustrated. Of course, I'm going to use this specific example. My point of emphasis is on these lone pairs of electron. Now that I've mentioned the concept of charge, now from the illustration using this concept of protonation, therefore, this is going to involve the interaction between ammonia and a proton, whereby we're going to see that the interaction between ammonia and a proton is going to lead to the formation of what we refer to as the ammonium ion. Therefore, in this particular case, generally I can just be able to just illustrate it using this specific example. But I've said that this particular ammonium ion, of course, is a tetra. This ammonia is a tetrahedral molecule that we're going to see. And that particular case, I'm just going to illustrate it using this particular example. Now, if you try to look at this, we're going to see that in order for us to try and understand this particular interaction that has occurred, the lone pair of electron that is going to be involved in this from the nitrogen group is going to be shared in order to form this nitrogen-hydrogen bond that we are trying to see being displayed in this particular case on the side of the ammonium ion. And therefore, if we try to look at this particular case, then therefore we can be able to illustrate the transition which has taken place between this ammonia and hydrogen. Now, using what we refer to as the curved mechanistic arrow, and this is going to be illustrated as such. So therefore, we're going to have this. If I try to just have a different illustration, so therefore we're going to have this nitrogen given as that, and therefore we're going to have this particular case, this mechanistic arrow, which is a curved arrow that is going to be used to illustrate the interaction between these two. So this is going to lead to the formation of this ammonium ion that I've given on this other side that has got a charge of positive. Then therefore, if we try to look at this, whenever the nitrogen was having those two pairs of electron, its charge was as we can be able to consider, then therefore its charge was 0. And basically the interaction between nitrogen and hydrogen lead to the formation of a positive charge, which is +1. So therefore, if we try to consider the formal charges for nitrogen and hydrogen, therefore we are going to see that hydrogen had a +1 charge, and the transition to this formation of ammonium ion is going to lead to the formation of a charge that is 0. Whereas for the nitrogen that consisted of a charge of 0 is going to lead to the formation of a charge which is +1. So therefore the movement of charges across products from reagents to the products, and therefore is basically the concept that is going to be illustrated using this arrow pushing mechanism. So if we try to consider in this particular case, therefore we're going to see that in some interactions whereby we are going to have reverse reactions, and therefore we are going to consider the movement of those particular charges in a reverse reaction, and that's the concept of deprotonation. And therefore we are going to see that if we try to look at the concept of deprotonation, this is going to be a loss of a proton from this particular ammonium ion. And as we said, of course, from a chemical perspective, then therefore we are going to see that whatever can be able to lead to the loss of this particular hydrogen ion or a proton is basically a basic substance. Now, if you try to consider this, then therefore we can be able to just illustrate that. And this is going to lead to the formation of this product, whereby we are going to have those lone pairs of electrons and the CH3OH illustrated as such. So in this particular case, this is a reverse reaction that is going to be basically a deprotonation reaction, and we can be able to just show these mechanistic arrows using those curled arrows as such, and this is basically what we refer to as a reaction mechanism. So in several of our organic reaction, we're going to see this being displayed widely as reaction mechanisms. So I hope that whenever I mention the concept of the reaction mechanism, then therefore we are going to employ this in trying to show that. So basically this shows the movement of lone pairs of electron. There are some cases whereby we're going to use curl arrows which have, of course, having this particular case. So if I try to indicate this arrow using those two specific points, and there's a difference between that one and this half arrow. So this is going to show the movement of one electron, whereby this is a pair of electrons going to be displayed as that full arrow being given as such. So therefore, as I've said, this is going to be of essence for us in understanding the reaction mechanisms that basically are going to be relied on heavily in organic mechanisms, which are going to be showed in various videos that we're going to discuss later. So catch us in our next video as we're going to look at some of the mechanisms which are going to be involved, especially on the concept of organic synthesis. Bye. God bless you.